Hello again, everyone. Right, in this video we're going to go ahead and we are going to bring in our enemy ship. We're going to make it so that our enemy ship can randomly spawn, that it will move downwards towards the player and off screen, and that it will fire shots back at the player. Okay? So, to get started, first things first, we need a player sprite. Again, depending on if you're coming from your own example project that we were doing in class, or if you downloaded the base sample project that I posted with these videos, you might already have your ship set up, but I'm going to assume that everybody does not. We're going to take the enemy-big.png image that I provided for you guys, and you're going to add it to the sprites folder in your project. Now, by default, that's going to go ahead and set it up as one giant image. So over here, you select it, and on the right-hand side in the inspector, we need to change the sprite mode to multiple. We need to change the filter mode to point. Okay. And then we can click apply. And then we want to go into the sprite editor. Now we're going to click slice. Set the type to be grid by cell size, and each individual image should be 32 by 32. You should be able to click slice, apply, and you've got two images equal size. Go ahead and close the sprite editor when you're done. Now back here in our hierarchy window, we're going to right click, we're going to do 2D object, sprite. It's going to drop in a new blank 2D object, 2D sprite. Now over in the inspector we're going to rename it to enemy. And then from our newly sliced sprite we're going to grab the first frame. We're going to drag it up here and put it in the sprite renderer's sprite field. Now in your scene, you can go ahead and grab it and move it so it's not directly on top of our player ship, just so we can see it. Go ahead and run your scene and you should see the enemy just sitting there. We can fly around, we can fire, nothing happens. Now, for our enemy ship, first thing we're going to do is handle movement. Just like the bullets and the player, we're going to use physics to move the ship, which means our ship is going to need a rigid body 2D. Our enemy is going to need a rigid body 2D. So you add component, rigid body 2D, and then make sure you set the gravity scale to 0. That'll ensure that gravity is not being applied to the ship. If gravity was turned on and you had a rigid body 2D, the ship would just fall straight down off the screen. Now, let's go ahead and go to our scripts folder down here in the project. We're going to right-click, create C# script, and we're going to call that enemy controller. And then we're going to double-click to open it. Now once Visual Studio finishes opening, it should go ahead and open up your enemy controller. If it doesn't, over here in the Solution Explorer, whether it's on the right or left hand side of your screen, open up Assets, and Scripts. And you should see your bullet controller, enemy controller, and player controller. The bullet controller and the player controller were already there from the project files that were provided to you. Alright. Now, for our enemy controller, we want the enemy to operate with the same base principles as the bullet and player, which means it's going to have a speed, and we're going to need to apply that speed to the rigid body that is attached to it to the enemy, so we also need to get a variable to access the rigid body. Now, when our start method is called, right away we want to call getComponent rigid body 2D and assign it to the rigid body variable. What this is going to do is, because we didn't specify in front of getComponent what GameObject we want to get the component from, it's going to default to the components of the object that this script is attached to. So if this script is attached to an enemy sprite, it's going to look for a rigid body 2D component and assign it to the RB variable so we can reference it. So once the RB variable has the rigid body 2D component attached to it, we can go ahead and say rb.velocity equals new vector2 0 speed. Now, what's going on here is we're saying for the rigid body, which handles physics for the object, we want to set its velocity, okay? So a constant rate of speed. Velocity takes in a vector2. Okay? Now this is a 2D game, so it makes sense that there would only be two vectors, an X and a Y direction. Now the enemy ship will always move downward on the screen, which means it's not going to move side to side. So its X value should be a constant 0. It's always going to be moving on whatever its current X-axis value is. It's never going to be assigned a value to move along the X-axis. And then speed. Speed is going to be plugged in the Unity editor as a constant rate of speed that we want applied to the object. If we're moving only one direction and we're moving along the y-axis, then we only need to apply speed to the y axis in the vector 2. Okay. So again, we get the physics object of the enemy, and then we apply a velocity to the enemy for a constant rate of speed. Let's go ahead and let's save this. Go back to Unity. Now take your enemy controller script and drag it and drop it onto the enemy. And if you select the enemy, you should now have an enemy controller script attached to it. Now what we're going to do is give it a speed of negative 0.25. Now the reason we give it a negative speed is that it's moving, this is the speed it's going to move along the y-axis. We need it to move downward, which means we need it to have a negative speed, okay? Positive would move it upwards. So now let's go ahead and let's run this and see how it plays. The enemy ship should just be moving straight down off the screen. And sure enough, yes it does. Now you notice, once I get off the screen, it doesn't go anywhere, it's still there. We switch over to scene and quickly drag out. We can see that the enemy ship still exists, it's still moving south, still being calculated. So let's go ahead and stop running our game. Switch back over to Unity. Now, let's open up the bullet controller. For the bullet controller, in the update method, we check to see when the bullet's Y position, according to the camera viewport, yes, exceeded 1. Now, in Unity, the camera, right here, its axis is 0, 0, value down here for X and Y, and 1, 1 for X, Y in the top right. So if you move above the top of the camera, you are greater than 1. If you are below the bottom of the camera, you are less than 0. Same for left and right. Less than 0 means you went beyond the left. Greater than 1 means you went beyond the right. Okay. So in Visual Studio, let's go ahead and let's copy what we did for the bullet controller in the update method. Go to the enemy controller and paste that in. Now, what we want to do is change this to be less than 0 because the ship is moving downward. So when the ship is below 0, destroy it. Now let's go ahead and go back to Unity. Let's run it, and I want you to watch the ship. Okay. Once it gets off screen, it went ahead and destroyed the object. It's disappeared. We no longer have to worry about it. It will no longer be in memory. It will not be having its speed and its position calculated, its collisions calculated. It will be destroyed and removed from the play state of your game. Alright. Now, right now we have a single enemy, and that's boring. We want to be able to create multiple instances of the same enemy. So, switch over to your Prefabs folder, select the enemy in the hierarchy, and drag it and drop it in the Prefabs folder. And it will go ahead and create an enemy prefab. If you go ahead and look up here in the hierarchy, you'll see that the enemy is blue, meaning it is based upon a prefab, whereas player and camera are based upon a individual one-off instance that was created here in the scene. Okay. Now, let's go ahead and in the hierarchy, let's delete our enemy. We no longer need this single instance of it. Okay. Now, over here in your scripts folder, let's create another C# script. Create C# script. Now we're going to call this one Enemy Manager. We're going to use this to manage enemies, to manage multiple enemies all at once. So go ahead and open up that script. Now everything we're about to do here will just take place in this script. It's going to use a timer to go ahead and check and see when a certain amount of time is reached. Go ahead and create a new instance of the enemy and place it randomly somewhere on the screen. There are a couple of ways we can do this. The way we're going to do this is using something called coroutines. So let's go ahead and walk through the code, and we'll set up the coroutine, and then I can explain a little bit more about the coroutine. So, first things first. If we're going to use a timer, we need to go ahead and create a timer variable to keep track of how much time has passed. So a timer would start at 0 and count upwards. We then need to go ahead and create another variable related to time. This one is at what point, once timer has reached a certain point, create a new enemy. Max timer is where we will store that point. So if timer starts at 0, max timer will be assigned something like 5 seconds. And when timer reaches max timer, spawn a new enemy. And then we're going to create a public GameObject, and we're going to name it enemy. What we're going to be able to do with this is, in the Unity editor, we'll be able to assign an enemy prefab to this field in the Unity editor, and that will go ahead and determine which enemy prefab gets spawned in. Doing it this way allows us that once we have it set up here in code, in the Unity editor, we can create different kinds of enemies and go ahead and just add them right here in the Unity editor to tell it, hey, for this enemy manager script, the instance of that script, we want you to create instances of this enemy or this other enemy. Okay. And we'll go over that when we finish the code and switch back over to Unity. So, when our enemy manager script begins, immediately we want to set the timer to 0, and we're starting from 0. And we want to set our max timer to a random time within a particular range. As you see, max timer is going to be set to a random value within a set range. Now range takes in a minimum and a maximum. And you need to know that the minimum is inclusive and maximum is inclusive as well in this case. If you were working with the C# object that uses range, and not this Unity specific one, the minimum is inclusive and the maximum is exclusive. But Unity's random range makes them both inclusive. Now I'm going to say that somewhere between every 5 and 12 seconds, I'm going to want to spawn a new enemy. So we're going to go ahead and just hard code those values there for now. Now right now on its own, the script doesn't do anything. Once it starts up, it sets these values and that's it. What we need to go ahead now is create a coroutine. So when our update method is called, we want it to go ahead and fire off a coroutine. To do that, we need to go ahead and say start coroutine and give it the name of the coroutine. We haven't yet written the coroutine, but we're going to call it spawn enemy timer. So when the update method is called every single frame, it's going to say, hey, if it's not been started yet, or it's been stopped for any reason, start the coroutine using the spawn enemy timer. And I have a typo right there. It should be spawn enemy timer. Now below all this, go ahead and create a new method called IEnumerator, not enumerable, enumerator. Spawn enemy timer. Okay. Now, coroutines have certain requirements, and one of those is that a coroutine has to call a method whose return type is an IEnumerator. Okay? Now, as you can see, right now our method doesn't return anything, which is why we're getting this error. Not all code paths return a value. So, let's write this method. Every single time that the spawn enemy timer is checked, first thing we want to do is, hey, let's check and see, is our timer greater than or equal to the max timer? If it is, spawn an enemy. We're going to do that by calling a spawn enemy method. Now this method has not yet been created, so go ahead and just type it in for now. We're going to come back to it in a second. Now, once we spawn an enemy, we need to reset our timer and get a new random time that we're going to create a new enemy. So timer goes back to 0, and max timer goes back to a new random range 5F, 12F. Okay? Now, whether or not timer is greater than max timer in the above code runs, each time we call spawn enemy timer, we're going to add to the timer counter 0.1. Okay? And we're going to set up the method to yield return. Now, yield is because it's a coroutine. Coroutines go ahead and operate by saying, I'm going to just be called, generate a separate thread on your processor, and I'm going to go do my own thing. You're not going to wait for the coroutine before the rest of the object or the rest of your application can run. Coroutines go work off on their own, and that's why we use yield. Think of yield like yielding with cars. You yield the right of way. A coroutine yields to the rest of the script. Okay? Now we do yield and then return. Remember, it has a return type of IEnumerator, so we've got to return something. And what return is a new wait for seconds, which suspends the coroutine execution for the given amount of seconds using scaled time. Okay? And we want it to pause for 0.1, for 1/10 of a second. You'll notice here, my counter goes up by 1/10, and I pause for 1/10 of a second. This ensures that timer is counting up via 1/10. Okay? And that's it. That's everything we need for the coroutine. Now to come back to our spawn enemy method, we need to go ahead and put that right there. Now spawn enemy is where we're actually going to go ahead and spawn in a new enemy. Spawn enemy timer just goes ahead and manages our timer and tells us when we are going to spawn an enemy. Spawn enemy will actually spawn, it'll actually instantiate the enemy game object that we assigned to the enemy manager and put it into the game. Now, the number I'm about to give you here, I found this number through trial and error. Okay? I'm going to go ahead and, back in Unity, show you this. I want my enemies to spawn outside of the range of the camera, so they don't just pop into existence. I want them to spawn somewhere up here and fly into the camera. I also want them to spawn somewhere between here and here. An enemy that spawns over here and moves down will not be in the range of the camera. That does us no good. So, back in your code, we'll go ahead and we're going to set up a new vector 3 called spawn point. And that's going to be generated from our camera main viewport to world point. Okay? Now, the viewport to world point can take in a vector 3. That vector 3 will be random.range 0, 1 floating point. The y variable that we created above, and 0. And before we move on, I'm saying I want to go ahead and I want to look at the camera that is in my level. I want to get the main camera. If there's only one camera, as we have, then main will refer to this camera. The name does not matter. It's that this is the only camera in the scene. So, use the camera object, go get my main camera. I then want you to go ahead and, when given a series of coordinates, like we are right here, we have vector 3, assume that this vector 3 is based upon the camera, the viewport, and then convert those values from the viewport to world points. Okay? If in my camera this is 0 and this is 1, this is 0.5, 0.5. Okay? But if you select the player, you'll see that in terms of world space, not just camera, but the entire game world, this position is actually 0, 0, 0. Okay? So, what this method does is takes a viewport value, such as 0.5, 0.5, 0.5, and translate it to the world point values, which would be 0, 0, 0. How this calculation works, you don't have to know the math. It depends on your camera position, all kinds of things. It's just what it can do, which is go ahead and take a series of values that are based upon 0 to 1 and translate them into actual world, a position in the game world that then can be assigned via either Unity or in code. So once we have a position that we know is between 0 and 1 and is 1.25 in viewport distance above the top of the camera, okay, we've randomly generated now this, wherever we're going to drop something up here, we're going to go ahead and, because of a fluke with Unity, we're going to ensure the z-axis is set to 0, and then we're going to instantiate, create an instance of the enemy game object that is assigned to this script. We're going to spawn it at the spawn point, and then we're going to go ahead and quaternion has to do with rotation. It has to do with rotation in space. Okay? We're going to say we don't want this object rotated at all. So just create a new quaternion object, a new rotation object, and give all of its values 0. Now, let's go ahead and save this. Back in Unity, on its own, Enemy Manager does nothing. It's not attached to anything. It can't do anything. What we want to do is, up in the hierarchy, right-click, do 2D object. Sorry, back up. You want to right-click and do Create Empty. And we're going to call it Enemy Manager. We'll then, from our scripts folder, drag Enemy Manager onto the Enemy Manager empty object. We then will go to our prefabs folder and drag the enemy prefab onto the enemy field of the Enemy Manager script. Now, to backtrack a little bit, we created an empty game object. Empty game objects are just that. They're empty. They're invisible. Yes, in the editor, we can see it, but it doesn't actually matter where you put it. It's still not going to show up when your game's running. I typically put empty game objects just outside the edge of the screen. You don't have to. You can leave them floating around in the center. You can go put them way far else. It's all up to you. I just like to go ahead and align them right next to my camera viewport, so when I need to select them or reference them, they're right there, as well as being here in the hierarchy. Now what an empty game object does is, it's literally empty. It doesn't have anything visual. See, you'll notice here it has a position, and that was it. I then added this script. Empty game objects are great for doing things like creating invisible taskmasters that will go ahead and manage something, like all of your enemies. This particular one will manage the spawning in and the timer that handles spawning in new enemies. If I go ahead and run this, we should randomly see enemies start popping up here. And they should come into view. They should all start scrolling down, and as they come off the screen, you should see a few of them disappear. If you want, you can go ahead and go to the scene view. You can see randomly enemies are being generated up here, moving south through here. And when they get off screen, they disappear. Perfect. Now, right now, our enemy can't be shot. We can't do anything about it. Our ship can fire bullets, but they can't touch the enemy. So what we need to do is we're going to add a component to the enemy called Box Collider 2D. This will add a collision object, a collision component to the object. So now, other Collider 2D components, whether they're box, circle, or otherwise, will detect when they've overlapped or intersected or collided with this collider. Now down here in Box Collider 2D, let's adjust the collider so that it matches the size of the ship a bit better. For whatever reason, once you make a change with the collider, editing the collider, it then unselects the collider edit. So you have to go down here to the bottom right and keep reselecting it and repositioning the different sides and corners and that of your collider. So now our enemy has a collider that is more closely aligned with the size of it. Now the collider is not the sprite itself. Notice up here that the cross point of my XY axis for the translation handle is still up here in the center of the sprite. That's because your collider has nothing to do with your actual sprite object and its size and shape. Now, let's go back here to bullet. Now our bullet, in order to know it's collided with the enemy, it also needs a collider. For this, we're going to use a Circle Collider 2D. And once it's added to the prefab of the bullet, we're going to go down here and edit the collider. That looks about right. Okay. Now I'm going to click down here in the Circle Collider 2D and set the offset to 0 and the Y to 0. Now, that'll go ahead and place it in the very center of my bullet. However, bullets typically they don't strike objects from their sides. They strike them head on. So, we're going to go ahead and down here in the Circle Collider 2D, for the offset, we're going to set the Y to 0.35. And that put it way up there. Okay, so that's not right. So let's go ahead and try 0.035. That looks much better. You can see there's the circle. I would say you could probably go down a bit more, maybe 4, 3, 2, 1. So we're just going to say 0.03. Okay. I'm going to go ahead and adjust the size of it a bit more. Zero out the x-axis again. Leave the y-axis movement at 0.03. Okay. Now our bullet is a bit more, it has a collision object and it's a bit more better aligned. Okay. So our enemies have colliders. Our bullets have colliders. Let's see what happens when we run the game and shoot a bullet at an enemy. Yeah, that's not right. Okay. Now what's going on here is both of these objects have rigid bodies, bullets and the enemy ship. They also each have a collider. However, we didn't tell the collider to do anything with this. Okay. We want the object to collide. They are obviously colliding, but then a bullet, when it strikes something, should disappear. And the enemy, when struck, should disappear. So, let's go to our bullet controller in Visual Studio. We're going to go ahead and add a new method called void on collision enter 2D. And this, if you pressed enter while typing in on collision enter 2D and it auto-populated, it gave you a parameter of collision 2D collision. Okay? So basically, what this does is, when the collider that is attached to a bullet enters or collides with another 2D collider, automatically pass in to the bullet controller the other collision object's information. So if my car crashes into another car, my car is going to receive a bunch of information about the other car. Now, all we have to do here is, we're going to say if the object we're colliding with, if the collision object we're colliding with is a game object with a tag called enemy, then GameObject.destroy this .GameObject. So destroy yourself. If the object we collided with is tagged as enemy, destroy yourself. Also, destroy the game object that is attached to the collider. So if my bullet collider hits an enemy collider and that enemy has been tagged in the Unity as an enemy, destroy yourself, i.e. the bullet, and destroy the game object attached to what we collided with. Let's go ahead and save this. And go back to Visual Studio. Now, let's select our enemy real quick and open the prefab. If you go ahead and look up here along the top, you're going to see something called tag. If you drop down the tag, see, there's no enemy. Now we know in our code we are going to look for an object tagged enemy. So click Add Tag, it's the little plus icon, and type out the word enemy. Click Save. Click on your prefab for your enemy again, open prefab, and set the tag to enemy. Now go ahead and run your game. Let's wait for an enemy to spawn in. Great. There we go. When the two objects collide, they are both destroyed. If you look over here in the inspector window, you're going to see that very soon only enemies that are out of the screen are registered. And as you destroy them, it goes ahead and removes them from the list over here. Alright. So at this point we should have an enemy that randomly is spawned in at various points and flies downward, and who can collide with your bullets, and when it does so, both the bullet and the enemy will be destroyed. In the next video, we're going to make it so that our ship, the enemy ship, fires back at us.